Alright, so in this problem, I have 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11. So I want to find the value of this. So for my solution, I'm going to rewrite my equation, my problem over here. So 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11. Now, notice how all of these terms here are the same. So I have all the same terms adding with each other. And if I have something in the form a to the power of b plus a to the power of b plus a to the power of b plus a to the power of b, I can simply just factor out a to the power of b from here. So I get a to the power of b times, well, a to the power of b divided by itself is 1. So I get a to the power of b times 1 plus 1 plus 1 plus 1. So in this case, I have a to the power of 11 plus itself 4 times. So I can factor out a to the power of 11, and I get a to the power of 11 times 1 plus 1 plus 1 plus 1. And now 1 plus 1 plus 1 plus 1 is equal to 4. So I get a to the power of 11 times 4. Now from here, a to the power of 11, I can rewrite this as 2 to the power of 3. All I did was rewrote 8 as 2 to the power of 3. And now 4, I can also rewrite this as a power of 2. 4 is the same thing as 2 squared. From here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of 11, that's going to equal 2 to the power of 3 times 11, which is equal to 2 to the power of 33, because 3 times 11 is 33. So I get 2 to the power of 3 to the power of 11, which is equal to 2 to the power of 33. So now I have 2 to the power of 33 times 2 squared. Now the last part is fairly easy step. Because both of these bases are the same, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So over here I have 2 to the power of 33 times 2 squared. I can think of a as 2, m as 33, and n as 2. So I can rewrite this as 2 to the power of 33 plus 2, which is equal to 2 to the power of 35. So this is my final answer, and I actually can't simplify this anymore because 2 to the power of 35 is a crazy big number. So this is my final answer. And also, the only way that this solving process could have been faster is in my first step over here. I took a whole 3 steps to rewrite a to the power of 11 plus itself 4 times as a to the power of 11 times 4, when I could have just saw that when it's the same term adding by itself x amount of times, it's just that term times x. So that's a faster way. Alright, so in this problem, I have x minus 2 to the power of 3 is equal to negative 8. So to solve this, I'm going to first start by adding 8 on both sides. So then these two cancel out, and I get x minus 2 to the power of 3 plus 8 is equal to 0. Now from here, I can rewrite 8 as 2 to the power of 3. So I have x minus 2 to the power of 3 plus 2 to the power of 3 is 0. And the reason I did that was because if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. So in this case, a is equal to x minus 2 and b is equal to 2. So I get x minus 2 plus 2 times x minus 2 squared minus 2 times x minus 2 plus 2 squared. And this is equal to 0. Now we can simplify this. So negative 2 and positive 2 cancel out. So I get x times x minus 2 squared is the same thing as x squared minus 4x plus 4. And then negative 2 times x minus 2, I can distribute the negative 2. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. And finally I have this plus 2 squared, which is equal to 4. Now from here, we can simplify what's in the parentheses. So I get x times x squared minus 4x plus 4 minus 2x plus 4 plus 4. So this simplifies to x squared. Negative 4x minus 2x is negative 6x. And now I'm left with plus 4 plus 4 plus 4, which is plus 12. This is equal to 0. Now from here, this gives me two equations. I get x is equal to 0, and I get x squared minus 6x plus 12 is equal to 0. So x equals 0, this is already a solution. And x squared minus 6x plus 12 is equal to 0. To solve this, we're going to have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 6, and c is 12. So if I plug these values in to my quadratic formula, I get negative 6 plus or minus the square root of b squared, so 6 squared, which is 36, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 6 plus or minus the square root of 36 minus 48 over 2 times 1, which is 2. And this is equal to negative 6 plus or minus the square root of 36 minus 48, which is negative 12 over 2. Now from here, negative 6 plus or minus the square root of 12 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is the same thing as the imaginary number I. So I get x is equal to negative 6 plus or minus the square root of 12i over 2. Now the square root of 12, this is the same thing as the square root of 4 times 3, right? Which is equal to the square root of 4 times the square root of 3. The square root of 4 is 2. This is equal to 2 root 3. So I get x is equal to negative 6 plus or minus 2 root 3i over 2. Now if I divide my terms here by 2, I get x is equal to negative 3 plus or minus, these two cancel out, square root of 3i. So my three solutions are x is equal to negative 3 plus the square root of 3i, x is equal to negative 3 minus the square root of 3i, and x is equal to 0.